My machine's running slow, but we'll muddle through it as best we can. I hope this recording will work. So as I said before, Jake, you weren't here. If you want to write this down, you can, or you can just watch, and if you stay to the end, I'll print this up for you. If you can't stay to the end, because I have no idea how long this is going to last, I will also email as an attachment a PDF copy of whatever we do today as well. And in theory, I'll also email you this YouTube video. Again, check your emails already, though. I sent you my 2 from the past couple of years in my old Math 12 course. So looking at the review, which I no longer have a copy of, are there any questions from here that you were saying, I have no idea how to do this at all whatsoever, and I've looked at your answer key and I can't figure it out? Please help me out. Now, if you haven't tried the question, at this stage, I'm going to say, please don't ask unless it becomes obvious that none of you have tried the questions. Then I guess we'll go that route. But I would prefer this to be dotting the I's and crossing the T's. What this is not designed is to teach you the entire unit from scratch. I think in one of my tutorials that I sent out already, I sort of do that. So which ones would you like me to go over? Questions on the review that you've tried and struggled with. The review that I gave you a week and a half ago. That review. So I'm sensing people haven't started the review. Be honest who has not started the review. Okay, so I'm going to change. Is there anybody that has questions from the review that they want to ask? So I need to change my gears totally here. Okay. Give me a second. I got to pause the video and let me think. All right, we'll improvise. Sorry, this won't be my best tutorial, and I apologize. I'm starting about 10 minutes later than I wanted to. Now we're going to jump on and turn your brains on. Here we go. Key ideas. First of all, we said this. Probability was defined as the number of successes over the number of possible outcomes. What that really means is, if you can count it, you can solve it. Let me give you an example. I'll print this up for you if you want. I'm not gonna wait for you to write stuff down. We're gonna move. Right here, number 4. I think there's another one with a wheel as well, which I think I didn't say I liked, but that might be a nice one to do as well. Here we go. Make it smaller, make it smaller. There we go. So here's a little spinner. There's various questions I could ask based on that picture right there. Let me make it a little bit smaller so you guys can get it all on one screen. So there's 2 spinners. Let's call this spinner here spinner A. Let's call this spinner here, help me out folks, spinner what? Sure, we'll do that. Looking at spinner B, what's the probability of getting an odd number? Looking at spinner B, what's the Christina? If you can count it, you can solve it. I mean, and this is really, really simplistic, but yeah, the basic way to start out is, well, count how many ways I win, divide it by how many ways there are. That's always the answer. The problem is very rapidly we get beyond what we can count. Witness picking 5 cards, for example. But that's our fallback, which is why we did combinatorics last unit. We learned how to count using shortcuts. Okay? But we can even answer stuff like this. It says the probability that the sum of the numbers indicated by the arrows is an even number is, okay. 2 spinners are shown below. One has 4 equal-sized areas. The other has 3 equal-sized areas. Assume they're spun once and each arrow stops in one of the numbered areas. First of all, it wants to know the probability that when we add these together, we get an even answer. First of all, we have to think a little bit. What gives us even answers? First of all, what 2 types of numbers are there? All numbers are either what or what? Odd or even. Okay? I notice here I have 2 even, 2 odd. In B I have 2 odd, 1 even. If I add, what gives me an even answer? Well, I guess there's a couple of possibilities here. think that's every possible I can either go odd plus odd, odd plus even, or even plus odd, and I would argue the bottom two are probably the same thing, but I wrote them just to be safe. If you add an odd number to an odd number, what do you get? I don't know. Let's make up an example. Give me an example, Rosanna, of an odd number. Too slow. Give me an example of an odd number. It's not a trick question. Give me something between 1 and 10 that's odd. 3, give me another odd number.
Plus 1.
Okay. 3 plus 1 is what? Odd plus odd is what?
Positive.
I don't care about positive or negative. Even. You know what? Right? What about even plus even? 2 plus 4. Also gives even? Okay. What about odd plus even? 3 plus 4. Odd. You're going to have to do some arithmetic, boys and girls. What about even plus odd? 4 plus 3. Okay. So this wants the probability that the sum of the numbers indicated by the arrows is an even number, and we're going to use this idea of a tree and if we can count it. This is already a medium complex problem. How do I know to do a tree? How many spinners are there? 2. Probably I'm going to have one level is what I got on the first spin. One level is what I got on the second spin. On the first level, I could go a 1 or a 2 or a 3 or a 4, but I think I'm just going to categorize it into odd and even. I think on the first spin, can get an odd or an even. Looking at spinner A, what's the probability that you get an odd number? Double check, they add to 1. Yay! Then on the second spin, I could get an odd or an even, an odd or an even. Looking at spinner B, what's the probability that I get an odd number? Down this branch, I got an even. Oh, you know what? I don't think this spinner is affected by what I got over there. I think it's still going to be 2 out of 3 and 1 out of 3. What do you notice, Erica, about these two branches? They are the, what was the fancy word for when the odds didn't change? Began letter I. Okay, independent. Looking for me?
Sorry?
Looking for me?
No.
Okay. Now we can answer the question. What does the question say? The probability that the sum of the numbers is going to be an even number. Walk down those branches based on my little chart here. Which ones will give you an even number when you add them together? Will odd plus odd give me an even number? Hey, that satisfies what we're interested in. Would odd plus even work? No. What about even plus odd? No. Oh, you know what? I think what I want is the first branch or the second branch. And that question right there summarizes almost everything we've done. We're using the concept that or means add. We're using the concept, what we're really saying is odd and, or sorry, let's write it up here, odd and odd. We're saying that and means what, Brooke? Yes. So that's why we're saying 2 out of 4 and 2 out of 3 for that left-hand branch. Oh, and we're saying even and even. What does and mean, Brooke? You just said it. Good. Thank you. And now I just got to be able to do the fraction math, and you can use the fraction button as far as I'm concerned, although I'd like to think that this is, multiplying is the easiest operation. It's 2 times 2 over 12 plus 2 times 1 over 12. Adding and subtracting, you need a common denominator. It turns out that we do have a common denominator. 4 out of 12 and 2 out of 12 is what? 6 out of 12, which reduces, oh, you know what? Holy smokes, the answer is A. I didn't know that, didn't see that coming, but there you go. Okay? So ideas that we want to emphasize is this then. Or, put in quotes, or is the same as add, but you have to minus any overlap. Now, we didn't need to worry. We just used or means add in the previous one, Brooke, because look at the spinners. They're not overlapping at all. They're two completely separate spinners. In fact, really, we were using the minus any overlap. That really only occurred when we were picking one thing. Let me give you an example. What is the probability of one card being a red ace? Sorry, being a red card or an ace. We're emphasizing the word or. Okay? How many cards are we picking here? Okay? Not how many cards are there. How many cards are we picking here, Brooke, my angel? And folks, I gotta say, please make sure you read the questions carefully. Please make sure you read the questions carefully. Yeah?
What is the probability?
What is, thank you. Typo, typing in a hurry. What is the probability? So here's what this is saying. Find the probability of red or ace. Here's what we said. This was the formula. It's going to be the probability of red. Oh, I don't want that. What the heck is that a symbol of? Stop automatically correcting that. Thank you. Plus, or means add, the probability that's an ace. Take away the probability that it's red and an ace, if that's possible. Are there red aces out there? Okay, then we are going to have to take that into account. If instead I had said being a red card or a black card, are there red-black cards out there? No! The and would be 0. This is going to be, how many red cards are there in the deck? Or how many aces are there? Could you put it in block H for me, dear? Thank you. And can you hand in any homework you got if you got it? 4 out of 52 minus how many red aces are there? Do I happen to have a lovely common denominator? Wait. You good?
I lost from it, but I
Ah! Nothing. You're back? Okay. Internet people are just terrified. Do I have a common denominator? It's a 5. Yes, I do. It's going to be 26 plus 4, 30 minus. You know what? It's going to be 28 out of 52. I only use this if it's stuff that I can count easily. My preference, to be honest, if I'm picking one thing, wherever possible, is to use a Venn diagram. Let me find you one from the review where I would use a Venn diagram, and I'll also try and show you how I spot it, because some of you are saying, I don't know how to start. Oh, that's not what I want. Firefox available. Apply, download. Let's just close Firefox for now. You know how I know number 2 is a Venn diagram? Here are some hints. I notice percentages. See it? That's a hint, maybe not. I notice 2 groups. See it? And they're either going to tell me both, or neither. In this question, they told me both. Or they're going to tell me neither. That's a Venn diagram question. I'm going to let you try that one. I'm going to see if I can find another Venn diagram question. Number 8. They didn't tell me percentages, but I'm seeing Chinese or Italian, 2 groups, and they gave me neither. I'm going to do number 8, but I'm going to change the numbers slightly. Of course, as soon as I read this, suddenly I'm starving. Chinese and Italian. Good food. Okay. In a recent survey, it was determined that out of 100 people, 70 had eaten Chinese food in the last year, 22 had eaten Italian food, and 20 had eaten neither. You know what? I'm going to make it 105 people. And I'm going to say 21 had eaten neither. There, now it's a whole new question. How many people had eaten both Chinese and Italian food in the last year? In fact, what we're going to say instead of how many, we're going to say this. Find the probability that someone has eaten both. Turn it into a probability question. I just noticed it's not actually asking a probability question. Do you see how I was able to see, though, Foster? This is probably best job for a Venn diagram. They give me and or neither. What's my Venn diagram going to look like? Ooh, hey, cool. I can go like this, Mr. Dueck. Ha-ha. I have Chinese food, Italian, and I'm assuming there's some overlap. I might end up with the overlap being 0, in which case they're, fancy word, mutually exclusive. But I bet you some people have had both, especially because this question is wanting me to find the probability that somebody had eaten both. Okay? What I said, Justin, for this approach is I would love to start in the middle and work my way out. That's why, and then we were subtracting our way out each time, subtracting from the and. Did they, read this question carefully, did they tell me the and? No. But I always still start there. How many people ate both? That many people. X. How many people ate Chinese food, grand total? Read from the question, Justin.
70.
How many people only ate Chinese food but not Italian? Not 70. Because if that had been a 19, you would have gone 70 minus 19 and put that number there. If that had been a 12, you would have gone 70 minus 12 and put that number there. In this case, do that. How many people had eaten Italian food, grand total? 22. How many people only ate Italian food but not Chinese? Not 22. 22. Take away X. And how many people had not, oh, these poor people, had not had Chinese or Italian in the past month? So far, so good. The last thing is to realize how many people are there grand total in the question. It says 105. See it? You know what that means? You with me? You with me? You sure now? Because otherwise you can go talk to whoever, but I'm giving up my free time, Angel. How many people are there grand total in this question? Thank you for coming through in the clutch. I was worried for a second. Now here's what that means. I have got every single group. That means that this combined with that, combined with that, combined with that has to add to 105. Has to add to 105. Now that I see this, I'm going to change the question. And instead of 105, I'm going to make it 95. Sorry, Jake, you're writing stuff down. I'm trying to do this in my head, and it's a tricky to do in my head. So it's going to add to 95. I just did that because I was worried the math wasn't going to work. We have an equation. We can solve for x. First of all, that x cancels that x because I have a minus x plus x. I can gather like terms. I got 70 plus 9 plus 22 plus 21. What is 70 plus 22 plus 21? You may need a calculator for that. I don't know, but I want to find it. Sorry? 70 plus 22 plus 91. It's going to be 100 and something. Chris, can you put it face down in the appropriate block? I need a definitive answer, not a question mark answer. 113? And there's still a minus x. That one there drops down. Equals 95. Solve for x. Okay. Put it in the red block? Okay. And any missing homework? Of which I'm sure there is some. You would go minus 113 from both sides. And you would get negative x equals what? Equals what? Somebody please go 95 minus 113. Is it negative 18? Oh, negative x equals negative 18. Divide by negative 1, divide by negative 1. Aha! X equals 18. X equals what? X equals what? That number there is 18. Now, believe it or not, we're done because they wanted the probability that somebody has eaten both. How many people ate both? 18 out of how many people grand total? 95. So the answer is going to be 18 out of 95. But I could have asked other questions because now that I know that that's 18, I know that this here is 52, 70 minus 18. Right? And I know that this here is, just 4, 22 minus 18. So now I could say, hey, what's the probability that somebody has only eaten Italian but not Chinese? 4 out of 95. Question? Okay. What's the probability that somebody has eaten Chinese but not Italian? 52 out of 95. Hey, what's the probability that somebody has eaten Chinese or Italian? 52 plus 18 plus 4 divided by 95. That's the other reason the Venn diagram is handy. I know on the written you can expect one question with a part A, a part B, and maybe even a part C where, Venn diagram is your best bet because everything falls out of there. Okay? Then we moved into the idea of and means multiply, but when there is more than one event. Let me show you what I mean. If you pick one card, what is the probability that it is a black card and an ace? Now there is the word and there, yes? But Brooke, read carefully. How many cards am I picking? 1. I'm not going to do a tree. You know what? I'm going to solve this by counting. How many black aces are there in the deck? The answer to this is 2 out of 52. And I'm not going to do some fancy schmancy multiply. You know what? It's that. It's that. Why didn't I bother saying and means multiply? Because I can count it. It's one card. Compare that with, suppose 2 cards are selected. What is the probability that you get, how about that you get 1 black ace and 1 red ace? Well, this can be done several ways. How many cards are we picking? 2. I'd probably choose a tree, although a bucket would work here. The bucket method, which I showed you for 5 cards, certainly does work for 2 cards. But I always start out with a tree because it's such a handy skill. Okay? Is this saying black first, then red? Or is it just saying one of each? Who cares? Okay. I guess on the first draw, you could get black ace, red ace, or other. And then on the second draw, you could get black ace, red ace, or other, black ace, red ace, or other. You know what? I'm going to leave this branch blank because I'm not interested in it. Now, because, Justin, I'm leaving a branch blank, my trick of everything adding to 1 will no longer work because I'm not doing a complete tree. So I'm not going to be able to fall back on that trick. Is that okay? Okay. Hey, how many black aces are there in the deck?
2.
So on this first branch here, I would have 2 out of 52. Justin, how many red aces are there?
2.
2 out of 52. Now let's walk down this left-hand branch. You picked a black ace. How many black aces are left?
1.
Out of, careful.
51.
How many red aces are left?
2.
Out of?
51.
Okay. I don't care about the other, and my trick of them adding to 1 isn't going to work because I'm not doing a complete tree. Down this branch, you picked a red ace. How many black aces are left, Justin, my friend?
2 out of 51.
How many red aces?
1 out of 51.
I really don't care about that. What does this question want me to find? One of each. Which branches are one of each? Black, red, or red, black? Is that okay, Erica? And we would then say 2 out of 52 and 2 out of 51, or 2 out of 52 and 2 out of 51. And the fact that I get the same numbers twice, I now notice maybe there's a shortcut. I could just go the first and then times by 2, but whatever. I should be using the same calculator you guys are using, right? Click. Let's bring up this guy. 2 out of 52 and 2 out of 51. Oh, heck. Times 2, because it just appears twice. Little shortcut. 2 out of 663, whatever the heck that is. Okay. It should be small. That's a small fraction. Well, it should be small, because what you're getting in 2 cards is 2 aces, which is a good poker hand. So, yeah. Okay. So we did and for a while, and then we moved into conditional. Let me find you an example of a good conditional here. That's 5 cards. That's a combinatorics. That's a binom. How do I know number 3 is a conditional? This is a weird conditional, so this one I will do with you. This is a weird conditional just because the English is strange. Trust me, you'll see why in a second, but let me walk through it. By the way, Brooke, also, how many coins are we picking or tossing? I think a tree. What if they said 8? I'd probably go binom, PDF, or CDF or something, because coins are independent, and 8 would be, I'm not doing a tree. Okay. Smaller. You guys doing all right? You're looking a little dazed, a little zoned. No, none of you have done the review, so that doesn't help. Most of you haven't done the review. Let's set up my tree first, and then let's interpret this. So it looks like I can have heads, tails, heads, tails, heads, tails. Or you could go heads, not heads, heads, but we got heads and tails. Hey, you flip a coin. What's the what are the odds that you get a heads versus tails? You know what? It's going to be a half, a half, a half, a half, a half, a half. Hey, is this bottom branch the same as this bottom branch? Yeah. What does that tell you? Independent. All right. Brooke, you identified that it's conditional. You're correct. What was the trigger word? Okay, this is going to be weird to write. This is going to be strange English. Read carefully. What's the given? Given what? At least one is ahead. Find what?
Both coins ahead.
Okay? What's that going to be? Well, that's going to be both heads, heads, and divided by, I'm going to do the at least one first. It's both over the given one. That's the dumb way I've told you that's worth dealing with this formula. It's called Bayes' law, and it can get really, really complicated, but I'm trying to keep it as straightforward as I can. And it's complicated. Don't kid yourselves. Which branches have at least one head? Does the first branch here, does that have at least one head? So it's going to include that. Does this branch have at least one head? Does this branch here have at least one head? Yeah. What about this last branch? So you know what? The bottom is going to be the first branch or the second branch or the third branch. Brooke, what does or mean? Yes. So it's going to be plus, plus. And you know what? It's kind of weird. Each branch is identical because it's going to be a half, or a half, or a half, a half. Why is each branch identical? Because it's a coin. It's a 50-50. It's kind of a boring question in that way, but it's okay. Now, see those 3 yellow branches that I've highlighted in yellow? Those are at least one head. What was the other event? Both are heads. And I said on the top, what you want is whichever branches are both 2 heads and at least one. Now, which ones are at least one? The yellow ones. Of those yellow ones, see them? Which ones also have 2 heads? You know what? The top is going to be that one. That's why I said the grammar, the English is weird, because the overlap between both heads and at least one heads is both heads. That's the overlap, which is going to be now I would just type this in really, really carefully. In fact, you know what? I would do the top in my head because it's multiplying 1 times 1 over 2 times 2. The bottom is going to be 1/4 plus 1/4 plus 1/4. You could use the fraction button, but that's what it's, right? 2 times 2, 2 times 2, 2 times 2, 1 times 1, 1 times 1, 1 times 1. Hey, on the bottom, what is 1/4 plus 1/4 plus 1/4? Yeah, you know what? You actually end up with, come on, computer. You end up with 1/4 divided by 3/4. And I think if you do that, you'll find the answer is B, 1/3. Okay? That's an example of a conditional. That's a bit of a tricky one. Which ones do I like? I certainly like the factory defective, non-defective one. Let me find one, Mr. Dueck. Certainly I like a marble question like number 11, except number 11, they didn't use the word given, they used the word if. Another synonym for given is if or suppose, but I'm pretty sure on your test I just used the word given because I did want to give you that trigger word. Okay? We did conditional, then we moved into combinatorics. Hey, here's a combinatorics question, number 10. How do I know the very first word? They don't want me to do a tree if I'm picking 5 things. So it's either binome or bucket. How do I know it's bucket and not binome? Because each time I pick a ball, there's fewer colors left behind. That means the odds changed for pick number 4. Pick another one, the odds change for pick number 3. Pick another one, that means it can't be binome. Binome was defined as the odds never change. Fancy word, independent. So, let's try number 10, but I'll change the numbers. So we went with the bucket. You'll notice, by the way, the bucket uses choose. Mr. Dueck, what if it's a permutation? What if they give you an order? What I said is if it's a permutation, that's actually what you're doing with a tree. Draw the first event and draw the second event and draw the third event. You can probably just write that one branch. If they give you the order, it's only, in fact, if they give you an order and it's 5 things in a row, I wouldn't use a bucket because I can do, if it's long as it's in order, one long 5 branch because it's only one branch. So, for example, if they said, find the probability of getting the jack, a black jack, followed by a red queen, followed by a red 10, followed by, I could just walk through each of those carefully and would be multiply. Bucket. like number 10. The bucket questions on your test are either going to be marbles or cards, probably cards, because it's a neat application, gambling. But here, marbles. Hey! Except, you know what? Since it's black, how about I use black? There, now it's a whole new question. Right? What do they want me to find here? Ooh, cases. As soon as you see at least or at most, list the cases. So at least 3 means what or what or what or what or what or what or what? I'll give you a hint. 3 or why can't I go 5 red? Okay, don't fall for that trap. I'll probably, right, there's only 4 in the, most I can have is 4 red, which actually made this question easier, because otherwise I could have been going 5, that'd be way more work. Bucket. When you draw your bucket, it has to contain everything. So if you're doing a deck of cards, make sure the bucket contains the entire deck of cards, which is why so often we added that second or third container of other or leftover or whatever. Here, we only have red and black marbles. I've got it all here if I go red, black. Jacob, my friend, how many red are in the bucket?
4.
Yes. How many black in my new modified question?
8.
Now, I'm going to do 3 or 4. What does or mean, kiddo?
Add.
Yep. So I dropped that down below the or. Let's do the 3 first. So from 4 red, choose how many?
3.
And I guess if I'm picking 5 from 8 generic, you know what? Let me do, this is a dumb way to draw it. Let me draw the arrow that way, and then I have more room. 2. What choose what? What choose what over what choose what?
4 choose 3. Plus 8 choose 2.
Why? He said plus. Why would I freak on him?
Oh, sorry.
Here it's,
Times 8
right,
choose
because
2.
it's
Yeah.
3 red
Yes.
and
Yes.
2 black. Or, and this is why I've tried to already from the last unit, help you keep those 2 straight. If you think that, it really does, even when I'm writing. And from 8 black, choose 2. Or
4 choose 4.
and
8 choose 1.
oh, you're right. I thought 0. 8 choose 1. And all of that is going to be over what choose what. Remember that built-in error check that I gave you? It's going to be front equals front, back equals back. But don't add all the fronts. I can do that one, or I can do that one. It's going to be from 12 marbles, you're choosing 5 of them. None of those will be the correct answer. I have no idea what the correct... Are you guys okay typing that in, or do you want me to show you how to type that in? Who would like me to show them how to type that in? Y'all good on that? Okay, so that would be a good question, although probably I'm going to ask you some kind of a card question. Why? Figure it out. I have a bit of a gambling thing, right? Partly because people do it so badly. I'm trying to teach you why not to. That was bucket. So if I go back really quick, oh, that's not what I want. If I go back and I look at the table of contents for our probability unit, we started out with just defining some probability stuff. We said, hey, if you can count it, you can solve it. We talked about related events. This is where we started saying, okay, we can use a tree if we're a little bit clever. We talked about odds. I've told you I'm not going to assess you on odds. We really got into the meat and potatoes on lesson 3. That was where I introduced, well, as a formula, this thing, which is on your formula sheet. But what I've said is, you want to simplify it, or means add, minus the overlap for one thing, or means add always for groups of things. Again, minus the overlap. But the nice thing is, if you're doing a tree, there can't be any overlap. Otherwise, your tree won't work, and it won't add to one going across. So with a tree, it's multiply down, add across, no overlap to subtract. That's also where we introduced the notion of a Venn diagram. Then, lesson 4, we defined and we really started flogging the tree. We said and means multiply. We did some practice questions there. Turns out you can solve an awful lot if you just really think carefully about what the tree looks like. I even gave you some weird, freaky ones where one marble was picked from bag A, put into bag B, shaken up, and then another marble was picked from bag B. We actually could handle that one too. You have to really think about the tree, but we could handle that one too. Then we did Bayes' law, conditional. Hopefully, maybe I let you... we talked about why you can't actually use a polygraph. We said even if a polygraph is 96% accurate, remember this one? Which they're not. Because most people will tell the truth, you're going to get a lot of false positives. A lot of people will fail a polygraph while telling the truth. That's why you can't use it in a court of law. We did the disease, not disease one. And I think I even talked about the depressing, instead of thinking polygraph and telling the truth, you can think racist and being a minority. And we said, sadly, unfortunately, you can show that if you're a minority, there is a strong likelihood that you will encounter racism. Sorry. It's much higher than you think, even though there's very few racists out there. We talked about O.J. Simpson as an aside, but that was all due to Bayes' law, conditional probability. I like Bayes' law because it gives you nice counterintuitive answers. Then we did the bucket. Okay? I made $1 from Jacob. Was it you that I made?
Roy.
From Roy. Okay? That's one worth filing in your back pocket. If you're ever at a party with more than 24 people, certainly if there's 30 people, if you can talk someone into betting $100, do it. This is not gambling. As soon as there's 34 people, you can crunch the numbers. The odds are about 98% in your favor. That's a better investment than any stock market. In all honesty, if I could talk somebody into betting $1,000 and there was 35 people in the room, I would in a second. That's far better than investing $1,000 in the stock market. Far better. Stock market, you might lose it. Here, I only got a 1% chance of losing it. Okay? It's a neat counterintuitive the birthday problem question. And again, the bet is not that two people were born on the same day. The bet is that any two people or more were born on the same day of the year. So they don't have to be the same age. They have to be born on the same day of the year. And you'll find you'll win. Okay? Bucket. Then we did the binomial. We spent a couple of days looking at this. This was a neat one if you were doing a bunch of events. In fact, on the quiz today, we had 200 phone calls on one of the questions. We can handle that. They use this to analyze, for example, election results, actually polling ahead of time. So they'll try and calculate the probability that someone will vote Liberal or will vote NDP, and then they'll say, okay, if we got X number of 1,000 people voting in the election, what's the probability that the Liberals win a majority? The probability that the Liberals were going to win a majority was very small mathematically in the last election. Did the Liberals win? In the last election last year, did the Liberals win? It was against every single poll and every single mathematical model. And that's also part of what I'm trying to teach you is probability only guides you in the best decision. I said I would bet $1,000 if there was 35 people. I would, but I might lose. There's about I think a 0.3% chance when there's 35 people. Could happen. The same way as you could flip a coin 100 times in a row and get 100 heads in a row. But would you ever bet that? No. That's all probability is good for. It's a guide. It can influence, it can guide your decisions, but it doesn't control the outcomes. Or the other way we say this is, we looked at the probability of winning Lotto 649. I think we did that in lesson 6 in the bucket. We said it's very, very small. And it is. You won't win the lottery, but someone does somewhere. Because the odds get beaten. So we looked at the binomial. We looked at the binomial PD. And you're going to have to know both. I guarantee on the multiple choice of your test, I'll give you a question and I'll say, as an example, looking at example 2, which of the following is the correct way of calculating it? And the answer won't be the answer. The answers to pick from will be that, or an 8 there and a 2 there, or an 8 there, or something else. I'll say you actually have to know how to do it the long way. You don't have to do it that way. but you have to know how to fit it in the long way. That's also on your formula sheet, your pink formula. Oh, I have a pink formula sheet right here. That's also on there under, number 9. And then number 10, I walk you through your graphing calculator on the binomial cumulative. I will not help you find the BPD or the BCD on your graphing calculator. I will expect that you can find those. I will not help you find NCR. I will expect that on your graphing calculator you know how to go option, arrow sideways, you know how to find those. That is part of your responsibility if you're going to use a technology. That's the test. I already told you which questions I like on the review, yes? So I've done that already. I'm not going to repeat that. Bare minimum, by Friday, you want to have done those. However, I won't accept the review from you if that's all you've done. I'll still make you finish the rest of the questions. And again, my answer key is online. If I noticed this morning and yesterday, my SkyDrive, which is where I store all my files, seem to be misbehaving. If you go online tonight to access my answer key and it's misbehaving, send me an email and I'll email all of you a copy of it out. The only problem is I can only email one file at a time, and the file I'm going to send you in about 2 hours is this here tutorial that I've kind of really quickly blazed through. Did anybody have anything else that they wanted me to explain? Yes, Erica, joy of my heart. Yes! I have an answer. Yeah.
And I didn't understand why.
Okay. So first of all, that's going to be when there's an at least or an at most. Okay? And so let me give you an example. Let's suppose there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of us in this room. And let's suppose, I'm going to make up the numbers here. Let's suppose I know that there is a 90% probability that any one of us has a cell phone in our pocket, a smartphone. What's the probability that at least 12 of us have a what's the probability that more than one of us has a cell phone? Well, that would mean more than one would mean 1 or 2 or 7 or 8 or 9 or 10 or 11 or 12 or 13, which I could do. But that would mean doing, I think I counted 11 a lot of calculating. The faster way would be to go the opposite of 1 or more. What's the opposite of at least 1? None. I would go 1 minus none. And that's where you use, if you want to find the opposite. So you use the complement if you're finding something and you're saying, oh, you know what? To find that something, I'm going to be adding 7 or 8 things together. Maybe it's shorter to go in the other direction and go 1 minus. Let me see if I can find you a question where it's actually worth doing that. I like number 16. Exactly. See, number 12, I see 12 putts, but exactly 8. Okay, I don't need to go 1 minus. I'm looking, at least 1 diamond. What does at least 1 diamond mean? I'll give you a hint. 1 diamond or? You need to know what the words at least and at most mean, and I can't help you with that. That's English, sorry. So this is why I always said, as soon as you see at least or at most, list the cases. So you ready? Let's do this one here. I'll change the question just slightly. Clip. So it says, determine the probability of getting at least 1 diamond. The key word here, Eric, and I'm glad you asked this because this is going to be on your test. In fact, I think one of the written questions does this. So the key idea, that means, oh, you know what? Instead of 3 cards, let's pick 6. Ha! At least 1 would mean What does or mean? Who wants to do 1, 2, 3, 4, 5, 6 buckets? What's missing? What's the opposite of at least one? Zero. None. Okay, you know what? Instead of at least one, let's make this at least two. What's the opposite of at least two? At least two would be... Another way to find two or more would be to go 1 minus 1 or less, which would be 1 minus 1 or 0. That would be way faster, because all I got to do is 2 buckets instead of 1, 2, 3, 5 buckets. You could do 5 buckets. You can survive, actually, without that 1 minus trick, but it's a lot of work. So this will be an example. I'm not going to solve this. Let me do a binomial example, because that's also where I'm going to throw it at you, okay? I'll make one up. Example. Suppose there is a 85% chance that a random person has a smartphone. If there are 13 people in a class, like we have here, what is the probability that at least 4 have a smartphone? What does at least 4 mean? What I mean by list, when I say what does it mean, what I really mean is list the cases. I'll give you a hint. 4 or, I can't hear you, you're right. Or, yeah. I could do them, and this is, by the way, how do I know this is binomial? How many people grand total? 13, so not a tree. Are the odds changing? No, each time it's an 85% chance that you have one, that you have one, that you have one, that you... So this is binomial. So I could go 4 or 5 or 6 or 7. You know what? There's a better way to do this, and the better way to do this would be to go 1 take away the probability of... What's the complement of 4 or more? Is that okay? Which in binom is going to be 1 minus that. Okay? So this idea, what we're really saying is, look, if you have every single possibility, it always adds to 1. So if the ones we're interested in are 4 or more, and the only other thing is 3 or less, if I can find 3 or less, which is quicker, I can go 1 minus, whatever's left must be 4 or more. Is that all right? Okay? And you can use that, in fact, I'm almost positive I'll make you use that for the binom somewhere. But you can also certainly use that for buckets. It can be convenient. You can use that for all sorts of probabilities. We did that a few times as well. Well, you're doing almost the same trick, by the way, with decks of cards. How many aces are there? What's the probability of getting an ace? 4 out of 52? What's the probability of not getting an ace? I hope you didn't count 48. I hope you went 52, take away 4. 48 out of 52. You went 1 minus just now in your head. Right? That's the other place we used it in filling in our tree. Is that okay? Any others? Anything else? That was a good, by the way, that was a good question. Christina, joy of my heart, light of my life.
Went over one thing in quiz number 3.
Quiz 3? What number?
I have 12.
Quiz 3. Quiz 3. Earth the quiz.
Okay.
I'm going to change the numbers and do it.
I don't know if you can change this one.
I'm going to try. I don't know. You're really assuming I remember all these quizzes.
Actually,
Give me a second here. Let me find it.
I think I know how to do it. I just kind of want to.
I don't know. Number 12?
Sorry, yes.
By the way, this quiz is, since you guys are here, really worth studying because I actually took my test, nuked about 1/3 of the questions, changed the numbers or changed the question completely but kept the same skill. In other words, this is a good indication of a lot of what you're going to see on the test. Number 12, what was that? Oh,
Maybe it was, I don't know if it just tweeted it
so yeah, on your test, I'm going to ask you about stuff that is, there's the magic word. What does that mean? What's the synonym for mutually exclusive? And you need to know this, sorry.
Can't happen.
You're correct, what?
Can't happen at the same time.
So, which of these can't happen at the same time? So, walk through each answer. Erica, did you want me to print this up, or I'll email this out for you, or you can grab it tomorrow, or whatever, okay? So I guess I'm going a bit longer still. What does B say?
The first diagonal is a pivot.
That's this row here. Okay, so you know what? Let me actually show you a visual way to think about this. Because maybe I went too fast, and that's on me then. Yoink. I'm really going to muck up this diagram, but that's a problem. Okay, undo. Undo. Down here, down here. Let's try that again. Let's put it in the right place this time, Mr. D. Yoink. That's better. Justin saying deep thoughts. Okay. What's event B? We're gonna look at each one of these answers. I just don't like the fact that they use A, B, C, D here and A, B, C, D here. I would have called this event 1, 2, 3, and 4 or something, but that's okay. We can figure this out. What's event B?
First diagonal is a pivot.
That's that right there. Right? What's event D?
The second diagonal is a hat.
That's that row right there. Hey, is there an overlap? Then those are not mutually exclusive. Let me erase those. Let's do B. What's event B?
The first diagonal is a pivot.
What's event C?
The sum of two dies is 0.
You know what? That adds to 9, that adds to 9, that adds to 9, and that adds to 9. Is there some overlap? Those are not mutually exclusive. You kind of see where we're going here? It's almost like that Venn diagram without actually drawing a Venn diagram. We're saying it's where the circles overlap. Hey, let's keep going. A and C. What's event A?
The sum of the two dice is 6.
That's here, 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 and here. What's event C?
The sum of the two dice is 9.
That's here, here, here. Any overlap? Those are mutually exclusive. I would quit here, but hey, let's do D anyways, just for practice. A is, the sum of the two dice is 6. I should have left that open. That was this row right here. B is the first die rolled is a 4. That's this row. Yep, there's overlap, so those are not mutually exclusive. Okay? I'll even be more blatant. I think the question that I asked you about this was talking about decks of cards. So I'm basically going to be asking you, can certain cards be the same thing? The obvious one, can a card be black and red at the same time? No. Okay. Those are mutually exclusive. I'm not going to ask you one that easy. But I think I gave you 4 possible card combinations, scenarios. Said which of the following. I either asked which of the following is mutually exclusive, or I asked which of the following is not mutually exclusive. In other words, which of the following is mutually exclusive, no overlap, or which of the following is not mutually exclusive, which of the following can happen at the same time. I can't remember what I asked. Is that all right?
Yes, thank you.
You're going to have to know what a deck of cards looks like. Sorry. No, I'm talking to my Angel Brooke. She's gotten so much better, though. I'm proud of her. Any others? We'll make a gambler out of you. No, we'll make an intelligent non-gambler out of you yet. Any others? You just felt like a little, put your hands up in the air, raise the roof kind of a thing there? Stretching?
Can you actually go over the questions you work on that are very important to start studying the test?
Can I go over the, which ones did I say were important? I guess I can repeat myself. Although ideally you would have written that down the first time and not lost the review. Yeah, but I got 3 other people who lost the review who are kind of wondering. So Jake and Justin, you better circle in a hurry. Are you ready? I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's everything so far. 17, 18, 19 so far. Then I said I didn't necessarily like Justin number 20. You with me?
Yeah.
Could you sit down, Brooke? You're screening him. Sit. Yeah, give me 2 more minutes. So I wasn't freaking out about 20. 21. I said I liked 25, 26, 27. I crossed out 31 and 32. Crossed out 33. I liked 34. That's binomial. I liked 35. There you go.
Thank you, sir.
You're welcome.